Hey, it's Mr. K, talking about Physics 30 Unit C review, question number 19. When EMR that has a frequency of this is incident on each of the metals, the metal that will emit photoelectrons that have the highest kinetic energy is metal blank. So looking up here, we have this graph, Q, R, S, and T. Now, on the y-axis is the current, on the x-axis is the frequency. So, essentially what we're looking at here, when we shine these lights, in a photoelectric effect, EMR of varying frequencies, Q, R, S, and T, these frequencies shown here, is it incident on each of the four different metals. The intensity of EMR incident on each of the metals is different. The resulting photocurrent is measured, and a graph of the results is shown below. So, first of all, we're talking about photoelectric effect. So we have a photon coming in, striking an electron, and performing the necessary work, and then ejecting it with EK. We're asking what will provide the largest or the highest kinetic energy. Well, let's say that this photon coming in has 3 bars of energy. Now, I want the EK to be as high as possible. So that means that I want the work function to be as low as possible. So if I've got 3 bars coming in, then that means that I want only 1 bar, like the lowest possible amount of energy taken for the work, and then the rest will go to EK. So if I look here, all of these different frequencies hitting all of these different surfaces, they're going to emit electrons at these frequencies. Now this one is a very high frequency and therefore very high energy. Now that means that 15 hertz is the work function here. So that is a lot of energy necessary to take this off. But then as we get lower and lower, there is a surface that you can get an electron off with just 4 hertz, or 4 times 10 to the 14 hertz, but a small amount of work. What that means is all the energy is left over for the kinetic energy. So what that means for us is that S has the lowest work function and therefore will have the highest kinetic energy. Thanks for tuning in.